Alright, so today we're going to do the law of cosines. And the law of cosines is what you're going to use when you're not given a matching pair. So anytime you're given information about a triangle where you know an angle and the side opposite, you're going to use the law of sines. If you're given all three sides, or if you're given two sides and the included angle so that you don't have a matching pair, then you're going to use the law of cosines. So just a quick, where does the law of cosines come from? It actually works from the Pythagorean theorem. So if I call this A, B, and C, then this is side C, this is side A, this is side B. To use Pythagorean theorem, we have to have a right triangle. So I'm going to drop down the altitude, call this H. We'll call this X, which means this is B minus X. Alright, so for this triangle, Pythagorean theorem would be that we have B minus X squared plus H squared is equal to C squared. Alright, so if we multiply this guy out, we're going to get B squared minus 2BX plus X squared plus H squared equals C squared. Alright, this, if you look at the smaller triangle, you'll see Pythagorean theorem for that says that X squared plus H squared is A squared. So I can replace X squared plus H squared with A squared. So we look like that now. Alright, so now I need for X not to be in the problem anymore so that I have only things that pertain to the outside triangle, that triangle ABC. Alright, so if I can look at this triangle, we know that cosine of angle C is X over A, which means X is equal to A times the cosine of C. So I can replace this X with A times the cosine of C. And then I have the law of cosines, except that we rearrange it and write it where it says C squared is equal to, I feel like I'm missing something. Oh, I left off this A squared. Like my formula is not right. I replaced this X and then I never wrote down that plus A squared right there. Sorry. Okay, so if I write C squared and then I put my two squared things together on this side, this will be A squared plus B squared minus 2, and I'm going to write it AB cosine C. Alright, so from here to here, all I did was replace this X with this information. And then from here to here, I wrote C squared on this side, and here I put these together. Not really together, I just put them in the front. And so you can have a similar argument and set it up where you can say B squared is equal to A squared plus C squared minus 2AC cosine of C. Or you can write A squared is equal to B squared plus C squared minus 2BC cosine of, this was not a C, y'all, sorry. This was a B, and this is an A. Alright, so, law of cosines has 3 formulas, but it's not necessarily that you need to memorize formulas. Alright, it's that you need to understand how the law of cosines works. So, it's side squared, and you do cosine of that angle. And then this is always matched. This is always the same, sorry. You'll have A squared plus B squared minus 2AB. So the other two sides squared minus 2 times those sides, cosine of the angle that matches this side. Alright, whether you understood all of that is not important. You just need to understand that this is the law of cosines. There's 3 different ways you can write it depending on what information you're given and what you're solving for. And then you just got to be able to use a formula. Okay. Good news with the law of cosines, anytime that I give you side angle side or side side side, that can only make one triangle. There's no ambiguity, so you don't have to worry about how many triangles. The only time you have to worry about how many triangles is if you're given side side angle. Okay. And so if you're wondering what the difference between side side angle and side angle side is, it's the order. So if I give you this side, this angle, this side, then it can only make one triangle. If I give you this side, and this angle, then there's a little bit that can be ambiguous about that. So if I give you two sides and a matching angle, that's when it's the ambiguous case of the law of sines. If I give you two sides and the other angle, then you know it's the law of cosines. Okay, so before we jump into doing some problems, I want to just real fast, can we solve this equation for n? All right, because law of cosines looks like this, and this is a lot of times what people get hung up on. So we're going to do, this is 9, this is 16, this is 49, and we can multiply all of this together. So 8 times 7 is 56. All right, so then I have to add these two together. Oh, look, I'm losing my mind. 3 squared is clearly 9. It's not 9 squared. So if I do 16 plus 49, and my brain wasn't wanting to do that, I get 65. And I can add these, but not this, because this is being multiplied by n. All right, so then it's an easy little two-step equation. Subtract the 65 from both sides. What is that, negative 56. And then divide by the negative 56. And you get that m is 1. All right, so the point of doing this was just to reiterate order of operations and how you're going to have to clean up a problem to be able to solve. So keep in mind, you can square everything and multiply these three numbers together. Then you're going to add these guys. I put that in the wrong place. You're going to add these. Then it's just a little two-step equation. Now when it's law of cosines, there's going to be a cosine in the mix, and we'll discuss how to do that in just a second. All right, so for number 1, we have one angle, two sides, and we don't have a matching pair. So we know we can use law of cosines, and we set up the same way that we've been doing. So I don't know side A, but I know angle A. I know side B, but not angle B. I know side C, but not angle C. So when you write it like this, you realize that there is no matching pair, and law of sines is not going to happen. So law of cosines is what has to be used. So I can find this side first, because I know two sides in this angle. I can use this version of the law of cosines. So I can say that a squared is equal to 9 squared plus 5 squared minus 2 times 9 times 5 times the cosine of 120 degrees. All right, so here is what I'm going to do. When you have one that looks like this, when you're not solving for an angle, instead of doing all of the work, I'm going to let the calculator do it for me. To get a by itself, I'm going to take the square root. So I know a is equal to the square root of all of this. And that's exactly what I'm going to put in my calculator. And honestly, if I'm writing this on my own paper, I don't even write this down again. I just like draw an arrow and say, take the square root of that thing up there. All right, so in my calculator, see if I can make it all fit on the screen. We're going to do second square root. We're going to do 9 squared plus 5 squared minus 2 times 9 times 5 cosine of 120. And again, we're in degrees. Make sure your mode is in degrees. And also, if you don't have a graphing calculator, your cell phone calculator will do this. You've got a square root button on there. You can type it all in, and you'll have a cosine button if you turn your calculator, your phone sideways. All right, so we get A is roughly 12.3. All right, once you use the law of cosines, then you're good to go. You have a matching pair, and you can use the law of sums. So setting up the law of sums, you can find angle B or angle C. It does not matter. So let's say we find angle B. So we're going to set up that we want 12.3 over the sine of 120 equal to 9 over the sine of B. We're solving for an angle, so we're going to inverse sine and then cross multiply divide. So 9 sine 120 over 12.3. All right, so in the calculator, we do second sine, 9 sine 120, divide by 12.3, and we get that angle B is 39.3 degrees. All right, so once you know two angles, you can find the third angle of a triangle just by subtracting. So we can get angle C by doing 180 minus 120 minus 39.3. And we get 20.7. All right, let's try another one. All right, so this one is different because it gives me 3 sides. Now, when you are looking at different textbooks, and I know that y'all don't just look at different textbooks, when you're given 3 sides, some textbooks say you have to work smallest to largest, some textbooks say you have to work largest to smallest. The idea is that your calculator only knows principal values. And so if you're trying to use law of sines to find your big angle, then it's not going to give you an obtuse answer. So my rule of thumb is when you're given 3 sides, always find the biggest angle first using the law of cosines, and then from there it doesn't matter what you do. All right, so make yourself a note to find the biggest angle first when you're given 3 sides. And then you'll never get things wrong. Okay. All right, so setting up my info, we have A, B, C. I don't know if I'm going to be able to write in the amount of space if I try to just use theirs, so I'm going to go ahead and write it out like we normally do. All right, so the biggest side is 40. So I'm going to find angle B first. So if you look back at our formulas that we just wrote down, let's see if I can make them show again. We have these 3 formulas for the law of cosines. All right, if I want angle B, then I'm using this version. Okay, so that means I'm going to say side B is equal to the other 2 sides squared and added minus 2 times both side lengths cosine of angle B. All right, so this is the one where you have to understand how to solve an equation and follow all of those steps correctly. So I'm going to try to do a few things at a time so it doesn't take as long. So if I do 40 squared, I get 1600. And then I'm going to go ahead and put all of that together. So I'm going to do 24 squared plus 18 squared and get 900. And then I can go ahead and multiply these numbers. So 2 times 24 times 18 gives me 864 cosine B. All right, so now I'm going to subtract 900. So 1600 minus 900 gives me 700. Then we divide by the negative 864. Doesn't matter if you put the negative on top or bottom as long as it's there. So then to find angle B, you inverse cosine this fraction. And I never divide that out and I never simplify it because you're going to inverse cosine, so second cosine, and then you just type in that fraction and you don't have to know what it is simplified. And if you try to get a decimal, then you're rounding in the middle of a problem and you're probably going to end up with a slightly different answer anyway. All right, so we get 144.1. All right, now, since you know a matching pair, you can switch to the law of sines. If you wanted to use the law of cosines for every single thing you find, then it doesn't matter what order you do things in. But most people like to switch and use the law of sines because it's easier, and that's where this little bullet comes into play. All right, so setting up our law of sines, we can say 40 over sine of 144.1 is equal to 24 over sine of A. All right, so we can say that A is equal to inverse sine, and then you cross multiply and divide. All right, so inverse sine 24 sine 144.1, close parenthesis, divide by 40, gives me 20.6. So let's put this in the calculator. Gives me 20.6. All right, and then again to find C, we can just do 180 minus 20.6 minus 144.1. My fingers are not cooperating. And obviously, hold on. Okay, much better. You get 15.3. Okay, so the next one I think you'll be able to handle on your own, so pause and try it, and then see how you did. All right, so we know A, but not angle A. We don't know side B, but we know angle B. We do know side C, but not angle C. All right, so this one is set up where we can use law of cosines to find B. So we'll do B squared is equal to A squared plus C squared minus 2AC cosine angle B. All right, so we're just going to take the square root of all of that, which is how I normally show my work because I'm a little bit on the lazy side. All right, so we're going to square root 12 squared plus 14 squared minus 2 times 12 times 14 cosine 39.4. And we get that side B is 8.96. So if we're rounding to the tenths, that'd be 9.0. All right. So now that we have a matching pair, we can switch to the law of sines. So we can say 9 over sine of 39.4 is equal to 12 over sine of A. And you notice here how I didn't find the biggest one since I'm using law of sines. Just try to be careful. Usually it's not a big deal unless it's one where you're given 3 sides, but just always try to kind of be careful not to find the biggest angle using the law of sines. I don't know what else I can say. So A is inverse sine of 12 sine 39.4 over 9. All right, so inverse sine 12 sine 39.4 divided by 9. And we get 58. Nope, that's not 58. It's 57.8 for angle A. Alright, and then to find angle C, we can do 180 minus 57.8 minus 39.4. And we get 82.8. Alright, I think this last one is also going to be one that you can try on your own because it should be another one with 3 sides. Yes. Alright, so pause the video, work this one out, see how you did. Alright, so we know side A, not angle A. We know side B, not angle B. And we know side C, but not angle C. Alright, so when I use a law of cosines, let's find the biggest angle, So biggest side is B, so we'll say 24.3 squared equals 19 squared plus 21.8 squared minus 2 times 19 times 21.8 cosine of B. Alright, so we're going to figure out this, we're going to figure out this, and we're going to square 24.3. So 24.3 squared is 590.49. And then 19 squared plus 21.8 squared is 836.24. And then 2 times 19 times 21.8 is 828.4. So then we subtract the 836.24. Then we're going to divide this over. They're both negative, so it'll be a positive. And then we can say that B will be equal to inverse cosine of 245.75 divided by 828.4. So inverse cosine 245.75 over 828.4. And that gives me 72.7 degrees. Alright, so from there we can set up the law of sine. So we can do 24.30 over sine of 72.7 is equal to, and it doesn't matter which one we find, I'll find C next. 21.8 over sine C. So we know C is equal to inverse sine of 21.8 sine of 72.7 over 24.3. Lots of decimals, so be extra careful when you put that in your calculator. And 58.7. Alright, so now that we know 2 angles to find the third angle, we can just subtract from 180 the 2 that we know. So 180 minus 72.7 minus 58.7 gives me 48.6. Alright, so that's a law of cosines. We will, Monday, we will do more law of sines, law of cosines, making sure we can decide when to use which one, and talk about some area formulas for non-right triangles, and if you're not given the right information to find the area of a triangle, you need to know a base and a height. Well, if I don't give you base and a height, but I give you enough information that you could use law of sines, law of cosines to find other things. There's a lot of work involved in that unless you know some formulas. So we'll talk about that. And then we'll do word problems on Tuesday, review on Wednesday, and test on Thursday. That is my plan. Let me know if you have questions.